Thank y'all for inviting me here today. One thing I want to ask as we move forward is remember the title of this session. This is a future vision for peanut grading. So clear your mind on where we are right now and think about where we can go to accomplish some of what Mr. T.E. said and some of Carl said. I think we can get there. It's going to be a migratory process that's going to come in stages. But before I start, I'm going to tell you right now, I'm going to say some things that you're going to agree with, some things you're going to disagree with, and that's true whether you're a grower, a buying point manager, or a sheller. But I'm just going to tell you what I believe in right here. In the future, I think we should move to a point, and Carl mentioned this, where all farmer stock peanuts should be cleaned and screened, and the LSK, farm material, and small kernels screened off prior to grading. It would help tremendously. Less LSKs, smalls, and farm material would improve the efficiency of grading, no matter what current or future technologies we use. In a 10,000-ton warehouse, on average, this would reduce farm material in that warehouse from 512 tons to 82 tons and greatly improve the aeration in those warehouses. Data shows from the PQEP project that we conducted several years ago that 35 to 50% of the LSKs can be recovered as edibles, and Carl mentioned that they are brought back in. LSKs should be captured and tested separately, and if acceptable on that test, growers should be paid for this edible portion at a higher price instead of a discounted 7 cents per pound. They're acceptable. They're going into the edible market. You should be paid for them. Yes, I know that screening and cleaning this amount of peanuts is expensive, but I think the costs are far less than the benefits. Here's a little data just to support what I'm showing. And let me say that I got the farm material and LSKs wrong on this. Which one's the center one? Okay, it's not showing up. There it is right there. This is actually the farm material. As you can see, the reduction in farm material. So one of the things that the two previous speakers said is reduce LSK. The other one was reduce other kernels. Mr. T.E. mentioned that those just don't store well. A significant reduction in other kernels from screening. And farm material, a significant reduction. If we can get to that point, what we're putting into the warehouses will go through the shelling plants much quicker and much more efficient and much less losses in the shelling plant. From an aflatoxin standpoint, it makes a big difference. This was data from 2011, which similar to 19, it was a difficult year. And this is after the shelling plant and through the electronic eyes, but not blanched and not remilled if necessary. But you can see significant reductions in aflatoxin, or the percent of loads that went out on aflatoxin in the jumbos, the mediums, number ones, and splits. So it does help us with aflatoxin tremendously to screen peanuts. Now, as we move forward, as I remembered, clear your mind. One of the things we know, Mr. T.E., is that the microwave moisture meter that was developed by Samir Trebelsi up at the ARS lab in Athens that y'all helped fund and promote, that is a very important instrument in peanut grading, and we hope to see more about that. But one thing we need to understand is not just the average of the moisture, but the distribution. We've done studies before that said you can have a 9% moisture, but within that same sample on an individual kernel basis, there can be kernels that are 18% moisture, 18% moisture. And that is going to cause tremendous problems in a warehouse, without a doubt. could even ruin, Carl, the entire warehouse. This can be done relatively inexpensive with thermal and digital imaging technology. We're working on this at the lab right now. You just take a sample of peanuts, you simply microwave them for a prescribed time, depending on the wattage of the microwave. The water molecules are going to excite faster than the oil molecules. And thermal imaging will pick this up, and we can actually digitize the size of the kernels and the size of that are high moisture and even damage within the kernels using this technique. And as we mentioned, high moisture kernels cause significant problems, and we need to allow for further drying to make that happen. And I'll talk about that in a little bit. We can also detect damage using structured light imaging. This is a slide from one of our labs up in Ohio. But you can use this thermal light imaging, and this is not on peanuts, to detect different levels of damage within a load. It's not technology that is available yet, but it is fast technology that can be incorporated in. There's also technology to look at segregating peanuts on aspergillus. This is simply looking at hyperspectral imaging, and as you can see, I'll move on down in the interest of time, it has a separation accuracy of roughly 80%, which is extremely good. Now, some of these machines are expensive, and we'll talk about that in a second too. This came out of Minnesota, and this is using basically near-infrared spectroscopy to look at different levels of aflatoxin. And this was done in peanut. And as you can see, we basically impregnated the peanuts with pure B1 aflatoxin, which B1 is our most prevalent, at 0 up to 1,000 ppbs. A total of 270 kernels were used, 30 per treatment. And down at the bottom, you can see that this machine classified, and we're just using two thresholds, 20 parts per billion and 100 parts per billion, classified these at greater than 90% accuracy. So we can determine the aflatoxin real quick with some of the new technology that is coming out. Now, why does it matter, y'all? And Carl's already alluded to this. We're doing a study on the cost of aflatoxin in the United States. And y'all, it is staggering numbers. If you look at a year like 2017, which was a relatively good year, actually it was a very good year from an aflatoxin standpoint, it still cost our industry $58 million in 2017 in a very, very good year. That's $30 a ton. An acre, or $16 a ton. Jump down 2 lines to 2019, which is one of the nightmares we're still just now getting over. Aflatoxin cost the U.S. peanut industry $126 million. $126 million. That's $91 per acre planted in the United States. That's $47 per ton of peanuts produced in the United States. And as Carl mentioned, we stopped exporting these into Europe at 63 cents per pound, and shipped them west instead at 52 cents a pound, because it was our only market at that time. But over this period, you can see that aflatoxin on this 3-year period cost us $84 million a year. $57 a ton, an acre, and $29 a ton. It is our #1 problem, and something that we desperately need to get a handle on quickly. So, if you look at these 3 years, and I'm not saying anything about any grading system or the way things are tested, but in 2017, only 0.06% of the crop was Seg 3s, if I've got the data right, roughly 2,300 tons. But yet, when peanuts come into the buying point and they're tested using the high-risk components of damage and mainly LSK, They segregate them based on this. And 330,000 tons were segregated in that year because it was a greater than the cutoff. In 2019, 1.6% were Seg 3s, yet 26%, Carl mentioned this number at 30% earlier, 26% were segregated based on chemical testing at the buying point, a whopping 530,000 tons. Now, are either of these right in my mind? No, neither one of them are right. The reason being is when peanuts come into a buying point and they are just getting flooded by peanuts, they're looking for the presence of Aspergillus flavus to determine Seg 3. That mold could have been on the peanut earlier, secreted the toxin, but not found visibly during grading. Or it's there, and it may not have yet secreted the toxin. It's only the risk or the visual presence of that mold that the graders find. So why do I say that Seg 1s based on high-risk components is wrong too? Because we're taking a concentrated sample of the high-risk components in that load, those that will be hot in a bad year, and testing those. So of course that number is going to be elevated compared to the edible peanuts. I hope I get that point across. But it's a way that shellers can manage inventory by doing this and to be aggressive in segregating lots that have high potential for aflatoxin from those that have low potential. So we know that aflatoxin is a huge economic stressor on our industry. In the short term, I'll go down to the bottom. Segregation and better detection methods are needed, but in the long term, we need to eliminate aflatoxin because we can segregate. If we come up with methods to segregate, you haven't changed the overall mass balance of aflatoxin. You've simply shifted it from one pile to another pile, but yet it's still the total amount of aflatoxin that was there. It just makes it easier to manage. That's why we need to find ways to eliminate or greatly reduce aflatoxin. In the future, and this is for farmers too, right now Mr. T.E. talked about the value of peanuts being mainly determined by sound mature kernels and sound splits. In the future of grading, I would like to see farmer stock peanuts graded similar to how shellers shell and sell peanuts. We get one SMK, but that's comprised of number ones, mediums, and jumbos sold into the edible market by shellers. I would like to see us get to that point. We do have small, high-speed rotary shellers that was developed in our lab and commercial or being produced by LMC Manufacturing that can do this very rapidly. And from here, it will sort the kernels through these different shelling chambers down at the bottom into jumbos, mediums, number ones, splits, and oil stock. Shell them this way, size them into these categories, and value them accordingly, is what I would like to see. The splits would be higher in the rotary sheller, but y'all, we need to eliminate the deduction for splits anyway. It was put in the old days when there was so much on-farm drying and we weren't monitoring it, and there wasn't a good, strong market for splits. Y'all, we have an extremely good market for splits right now, and a lot of people know how to dry their peanuts. And this is a deduct that takes a few dollars from growers that I think they don't deserve. And then we should chemically test the edibles at farmer stock grading to reflect the commercial market. Put it on the same basis so that the signals that go through the industry are the same. There are a lot of advanced technologies that can be applied to grading. It's very expensive if it's done right. And we've seen some of these, and we're working on a lot of them now to apply them to peanuts. The problem is, y'all, individual buying points cannot afford this. They don't have enough volume to spread this investment. They don't have it. But I'm somewhat in favor of a change toward a community or a regional-based approach to grading, which would have higher volume to spread these costs around, over and still be able to afford it. And Mr. T, I hope you see what's in the underline there. This would still be done, sir, by Federal State Inspection Service. Several shellers are using high moisture grading or buying points. This would help in this process. It's an approved process, and I was staggered by something Nate Tickner told me, that roughly 300,000 tons were graded at high moisture. I thought that was a very good number. But using high moisture grading would help because the sample could be taken when farmers deliver peanuts or if they had to be slightly dried, but when they're at 18% moisture content, okay? Delivered by a courier to the community buying station or regional buying station. While the peanuts are now being dried, the sample's drawn, the peanuts are going to Federal State, the sample's dried. The grade data could then be electronically pushed back to the buying point before the peanut drying process is completed. So when the peanuts are dried, the buying point manager would say, yes, they're at an acceptable level, and then the peanuts can be put in the warehouse and that conveyance freed up to go back to the field for the farmers in a lot quicker timeline, And I think this can work, and I think it would help, but it's just a lot of logistics that would have to go into it. We also need to work with our advanced equipment manufacturers. Instead of having shelling plant size sorting and testing machines, we need to have some tabletop units developed for us that would be a lot lower flow rate and a lot more affordable. But this is my future vision of the grading system. It won't happen soon, but I think that we need to have the consistent signals at the farmer stock grade that go all the way through the shell stock grade and ultimately into the manufacturing plant. And right now, I don't think we have it. Can we get there? I think if we plan forward, we plan carefully, I think we can. And I think it would benefit our entire industry if we could ever get to that point. Thank you.